Frequently referred to as special K or cat volume on the street and found in pill, liquid injectable, and powder form, ketamine can have profound effects on the brain and body. It affects many receptor sites, but the one it gets to the most, and the one that we're going to focus on, is the NMDA or N-methyl D-aspartate receptors. The antagonism of NMDA receptors and subsequent dulling of glutamate's intended effect is responsible for most of ketamine's effects in the central nervous system. Let's look at exactly how ketamine affects neurons. First, we see normal activity of glutamate in the brain. Glutamine is released by glial cells into the presynaptic cleft, where it is met with the enzyme glutaminase produced in the mitochondria. Glutaminase changes glutamine into glutamate, and then it's packaged into the synaptic vesicles with some help from a magnesium ATP-dependent transport system. Once the synaptic vesicles filled with glutamate make their way to the active zone of the presynaptic terminal and dock, they are then released into the synapse, where they can team up with glycine in order to unlock the NMDA receptors on the postsynaptic cell and allow sodium to stream in. When we introduce ketamine into the synapse, this process is interrupted. The ketamine blocks the already opened NMDA receptors, clogging them and not allowing any sodium into the postsynaptic terminal, therefore dulling glutamate's excitatory effects. This dulling of glutamate's intended effects is what leads to ketamine's effects, which can include analgesia or pain killing, amnesia, loss of consciousness, and immobility or an overall dulling of sensation, which recreational users refer to as hypnosis or a K-hole. At extremely high doses, it can lead to near complete paralysis and amnesia, or even psychosis, but at lower doses, it might be able to help those with depression. Whatever it may do, I'll never hear ketamine without thinking of a tranquilized cat, and now you won't either.